A very good afternoon to the ASM authorities. My name is Samarpan Majumder and I am going to present you the EDI code for the oral presentation competition. EDI code deals with the development of an edible coating from the peel extracts of citrus lemon and leaf extracts of Ocimum pheniflorum. Now these extracts are being enriched with the help of the polysaccharide, that is the chitosan, which is very helpful in increasing the ripening period of fruits, thereby reducing the chances of post-harvest losses. Now moving on, I present you my team of 3 members, myself Samarpan Majumder from IEM, Sagni Datta, who is my fellow batchmate from IEM, and Shomo Shahoti Ganguly from IIT Kharagpur. The research that will be presented today is actually a joint research activity conducted by both the education institutions, and for this research I want to acknowledge BCCI, that is the Bengal Chamber of Commerce and Industry, for their funding provisions and constant incubation support. So in this presentation I am going to discuss about the problems that have been identified, the methodologies that are present in this particular research, and the main results and also the future scope of this edible coating. Now moving on, for the problem identification we have identified 4 types of problems. One is the lower shelf life of fruits, which is in correlation with the high amount of post-harvest losses in India. As you know, in India around 63,000 crores of the post-harvest losses occur every year, and which is also in correlation with the lower shelf life, because if the ripening period is extremely high, which basically means that the quality of the fruits or the quality of the post-harvest products are at a very high risk of getting denigrated in quality. And the third major reason for this post-harvest loss is also because of the cold chain efficiency. As you know that the presence of innumerable loopholes in the cold chain process right after the harvest to distribution in markets are extremely high and is going on increasing day by day. And the major reason is due to the lack of efficiency of the post-harvest cold storages that are being used in the farming sector. And the fourth major reason is the high carbon footprint of the farming sector. In this particular point, we have to note that during the ripening process, the major reason why the ripening process occur is due to the emission of the carbon dioxide from the fruit walls. So this edible coating that we have developed, it is basically acting as a physical barrier to stop those biochemical processes to occur, and as a result we are increasing the ripening period. So this research has been performed only on one type of fruit, that is the banana, and the major reason is because banana is one of the most widely consumed tropical fruit in India and also in Asia, and is also the major contributor of the carbon footprint. So therefore the research has been performed on bananas, and for future scope we are trying to experiment on other fruits as well. The major ingredients for this particular edible coating developed are 2. One is the citrus lemon, another is the Ocimum pheniflorum. Citrus lemon, as we know, it is having antibacterial properties in them already. So this is basically reducing the chances of any infestation through bacterial infestation or insecticidal infestation. Whereas Ocimum pheniflorum, it basically restores the quality of the fruits by slowing down the secretion of the ethylene gas. The ethylene gas is also a major contributor of the ripening process. So therefore this particular ingredient in the edible coating is reducing the denigration of the quality of fruits by slowing down the secretion of the ethylene gas. For tackling this problem, there were 2 ways in which we could go. One is by developing a cold storage, or other is by developing an edible coating. Cold storage is not really a suitable option for us because we did not have access to high amount of funds. So therefore we wanted to tackle this problem for grassroots cause. So therefore we had developed an edible coating with the oil steam distillation extraction process, and after the extraction process has been completed, trial and error process has been performed because there is no definite way in which we could determine or reckon the perfect mixture or the composition of the edible coating. So therefore we had bought around 7 kilograms of bananas, which is around like 35 bananas. So we have divided we basically divided this entire group of bananas into 5 groups. So therefore 7 bananas in each group for 5 groups, and we have experimented with 5 optimal mixture compositions through which we have done all the experiments. So as you can see that after the edible coating has been found out, that is the optimal mixture of the edible coating has been found out, that edible coating has been applied over the fruits. So that is around like 1 liter of edible coating, which can suffice around 25 kgs of bananas. So that's almost a huge amount of bananas that we are trying to protect with this edible coating. Now in this section I'm going to discuss about the 4 different tests that we have performed to um, not only ensure that the edible coating is working at its optimal level, but also to make sure that the fruit quality is being restored. The first test is the ascorbic acid content. The ascorbic acid content is nothing but the organic acid content that is present in the fruits. So lower the organic acid content in the fruits, which means that lower is the quality of the fruits. So therefore, we have applied 5 different mixtures, as you can see, as already discussed before. One that is represented by the black line, that is the chitosan. Second is the chitosan and lemon, that is represented by the orange line, and then the yellow line, that is the chitosan and tulsi extract, or the chitosan and the ossimum terniferum extract. Then comes the green line, that is the chitosan and extracts of lim, that is citrus lemon and ossimum terniferum, and the normal tapped water. So the compositions can be seen in the right hand side of the slide, and this remains constant for all the tests that we have performed. So as you can see from the graph, that if we are using the chitosan enriched with 2% lemon peel extract and 2% tulsi leaf extract, the ascorbic acid content is retained for the maximum level. That is after the period of 15 days, that is the total incubation period of the entire research. After 15 days, the maximum ascorbic acid retention has been done with the help of chitosan and tulsi and lemon extracts. And this has been followed by the AOC method with 2,6 dichloro into phenol trimethyl method, and the rose pink color has been founded in the 19th second of this experiment. So this is basically nothing but the deliverable of the experiment that we performed. Next comes the antioxidant activity. The antioxidant activity is basically the quantification of how far the edible coating is able to reduce the secretion of oxygen or the secretion of the acetylene gas, or even the carbon emissions of this particular fruit. So as you can see, that is again shown by the green line. The chitosan, which is enriched with lemon and tulsi leaf extract, is showing the highest amount of antioxidant activity. That is, it is able to retain the highest amount of ethylene gas, the highest amount of oxygen that is being restored in the fruit, and therefore the ripening period has been increased to its optimal level by almost 2 days. So therefore, we are rightly able to reduce the oxidation process or the redox reaction processes that have been taking place with the fruits during this ripening period. Now for the phenolic content test, uh, the the Folin Kiyosaki method has been used, where the reagent was mixed with 0.1 milliliter sample of this particular edible coating, and therefore, as you can see again, for the phenolic content also, the highest retention for the first time ever in this research has been noted, where we are finding that with the help of the chitosan mixed with lemon and tulsi leaf extract, we are able to retain the maximum amount of phenolic content in the fruits. So which means that the maximum amount of polysaccharides or the main nutrients that are being present in the fruits are being retained. Next comes the soluble solid content. So this analysis estimates the amount of organic acid content of the bananas during the storage period. So the readings which were taken, were taken for a period of 8 days, from the 0th day to the 8th day, and then with a gap of again 8th day to the 16th day for all the samples. The results provide a better understanding of how the organic acid content decreases over time, mainly due to the loss of organic acid substrates during the process of respiration or transpiration or any other known metabolic activities of the fruit after the harvest during this particular ripening process. So for a period of 16 days of storage, the soluble solid content was assessed and suitable reasoning for such variations were assumed, such as dehydration and other activities which are followed with the particular biochemical processes. As you can see again, for the chitosan and lemon peel extracts, the variation in the titable activity and the variation in the soluble solid content for the period of 16 days is minimum, which basically ensures that with this particular edible coating, we will not only be able to reduce the highest amount of carbon footprint, we are not only able to retain the maximum amount of phenolic content, we are not only able to maintain the highest amount of antioxidant activity, but we are also able to maintain the highest amount of organic acid content in the fruits. So a visual inspection was done for both the fruits with coating and without coating. As you can see, with coating, the freshness percentage was like around 96.89%, and for the without coating, it is like around 8.167%. The carbon footprint sequestration calculation has been performed, and it has been seen that with the available edible coatings that are present in the market, the bananas, they basically emit like around 3.74 pounds of CO2 per banana if you're using the edible coatings that are present in the market. But if you are using our developed edible coating, then it is being reduced by almost 40%, that is to 2.29 pounds of CO2 per banana. So therefore we are also reducing the carbon footprint of the bananas. Now the final experimental results, as you can see, like it's a gist of all the experimental results that have been performed. First is the increase in shelf life. For the first time, our research has yielded an increase in the shelf life of bananas by at least 2 days by arresting the ripening period. And for reduction of the carbon footprint, there has been a reduction of 40% reduction in the carbon footprint for 1 kg of bananas from 480 grams to 288 grams of CO2. So this 40% reduction is actually a huge reduction for the bananas in the farming sector. Next comes the incubation opportunities that we have been given by the Bengal Chamber of Commerce and Industry. So we are trying to incubate this product, and we are trying to distribute this product into the global market as well as in India. So we have done a cost analysis of the particular product. So the base price of this existing edible coating is like around 750 INR. Now this 750 INR is in Indian rupees. This is for the edible coatings which are already available in the market. But the base price of our edible coating would be around 470 INR. So there's a 40% reduction in the cost for the same amount of quantity of edible coating that we have performed. So this reduction in cost additionally indicates that the product shall be more useful to the farmers over the existing ones in the market. So we are trying to introduce this product into the market and to the farmers through the monthly ration that they get from the Indian government. So the ration is basically a sort of I would say a supply that is given to the farmers, which include fertilizers, their monthly food. So we are trying to incubate this product through that particular ration so that the farmers can buy this product with a much lesser cost and it will be benefited to the maximum amount. So right now in the technology readiness level, in the global scale, we are right now in the stage 6, that is in the system test, launch and operations. We are almost done with our system test, launch and operations, and we are right now in the process of distributing this particular product in the market. So we are hoping that within 2 to 3 months we would be able to distribute this product in the market, and the farmers would be the ones who would be much more benefited for this particular with this particular edible coating. And since this edible coating is basically not only decreasing the post-harvest loss, now decreasing the post-harvest loss is also in proportionate to the increase in the economy of the farmers. So this is basically promoting, or this is also adding up to the circular economy. So therefore the farmers are not only able to increase their own economy, but they are also able to reduce the post-harvest loss. Now moving on, the main differentiation factors of our edible coating with the edible coatings that are available in the market. One is the better quality of edible coating that we have harnessed. Second, as already discussed, the lower carbon footprint. Third, has already been discussed, that is the higher shelf life of the bananas. For the very first time, we are increasing the shelf life of fruits of bananas by almost 2 days. So this is a huge experimental milestone that we have achieved with this particular research. And also the low cost of oil, that is the present cost of oil is around 750 INR, and we are reducing the cost by almost 40%, that is to 470 INR. And the technical validation has been performed with this particular research paper, where with a similar amount of the experimental tests that have been performed, our edible coating is far ahead of the other edible coatings that has been harnessed, and the variation in quality is in the positive side of around 6 to 10% for our edible coating. So that ends my presentation, and thank you.